Hello my dear students, this is Akash SD and welcome to the ASD physics classes. So students, I hope so you are doing really great for the upcoming JEE exams, is it? So today we are going to see the questions based upon NEET and JEE exams, and here in this we are going to learn how to deal with the questions of thermal properties of matter. And here when we are mixing some different matters, like matter exists in three forms: solid, liquid and gas. So here ice, water and steam. So sometimes what happens that when the state of matter is not same, that means we can tell we are mixing ice and water, or we are mixing water and steam, or even we are mixing steam and ice also. So in these questions, how to solve the question in a very easy manner way. Okay students, so let's see the question and let's after that learn the basic concept also. Then all these questions will be very easy. Okay, so see the question here. The question is 1 gram ice at 0 degrees Celsius is mixed with 1 gram steam at 100 degrees Celsius. Find the final temperature and composition of mixture. Okay, so students, to deal with these questions, the concept is, students, the concept, let's take for example, I have ice at minus 10 degrees Celsius. Okay, and I want to make it steam at, for example, 150 degrees Celsius. Okay, so what are the steps are involved? Steps are involved. So see please here. First we'll make here ice minus 10 to ice 0 degrees Celsius. Then we'll make it here water 0 degrees Celsius. After that we will make it to water which temperature? 100 degrees Celsius. After that we'll make it steam at which temperature? 100 degrees Celsius, and then only we'll go to steam 150 degrees Celsius. Okay, and here the heats involved will be, let's take here Q1, here Q2, here Q3, here Q4 and here Q5. During the Q1 what is happening? During the Q1 what is happening? The state is not changing, ice to ice. So here we have to use the formula MC ice into delta T. M is the mass, delta T is the change in temperature, and remember that please. This specific heat capacity value of the ice will be 0.3 calorie gram inverse degree Celsius inverse. Even you can write Kelvin inverse also, because change in temperature on both the scales will be same. Okay, similarly if I talk about here Q2, what is the Q2? Here you can see ice 0 to water 0. Here what is happening? The state is changing, temperature is not changing. That means here we have to use the formula M into LF. And what is LF? Latent heat of fusion, and its value is how much here? LF value is used to be 80 calorie per gram. Okay, next one, if I talk about here the Q3, during Q3 what is happening? Water 0 to water 100 here. Okay, state is not changing, temperature is changing. So here we have to use the formula here MC water into delta T. Okay, and specific heat capacity of the water, very easy, we have to remember that here directly, 1 calorie gram inverse degree Celsius inverse. Okay, next one Q4, here what is happening? Water 100 to steam 100. Here state is changing, so Q4 will be what here? M into LV, and you know what is the LV value? 540 calorie per gram. Sometimes even they will tell 539 also, no problem. And the last one is the Q5. Last one is the Q5. And what is the Q5 here? See please, steam 100 to steam 150. Here we have to use MC steam into delta T. And specific heat capacity of the steam will be 0.48 calorie per gram. All these values you have to remember that. Here again I am telling, specific heat capacity of the ice, latent heat of fusion during the state change, specific heat capacity of the water, latent heat of vaporization during the state change, and specific heat capacity of the steam. If these values you remember, then all these questions will be solved in a very easy manner way. Okay students, so now what we are going to do, now we are going to enter into the question. Okay students, so let's solve the question now here. So again you go through the question, I will just rough all these things. I hope so the basic regarding all this is very clear. Maybe this video will become somewhat long, but still you are going to learn a lot of things in this video. Okay, so see please, we have ice at 0 degrees Celsius and we have steam also. Both are in a different state. So first what we'll do here, we are going to condense the steam. Okay, so we'll write here heat released to condense steam and make it water at here steam and ice is there. You can take any temperature you can take 100 also, you can take 0 also. That one we will understand with experience only. It used to come that here. Okay, but here let's take, I am taking a 100 degrees Celsius. Heat released to condense steam and make it water at 100 degrees Celsius. That means what will happen that here? Steam 100 to water 100. That means here what is the latent heat of fusion? Formula M into LV, latent heat of vaporization. Is it? So M how much here? M is the 1. Latent heat of vaporization 540 calorie per gram. Na? This is gram, so calorie per gram, it will come how much here? 540 calorie. That means when the steam will become water at 100 degrees Celsius, this much heat will be released. Okay. Now after that, what I am going to do here? I am going to say here, this ice is there. Na? Let's take heat required. Heat required to melt ice and make water at 100 degrees Celsius. Now I have chosen common temperature 100 degrees Celsius. By seeing the data, we can get very good idea. Okay. So here what will happen that here? First it will become ice 0 to water 0. That means in this situation we have to use M into LF plus water 0 to water 100. That means in this situation we have to use MC water delta T. Okay. Now mass very easy, 1. So 1 into 80 plus 1 into 1 and change in temperature 0 to 100. That means here 100. So if you will check out here, how much is there? Students, you can see here please, 180 calorie, 180 calorie. Now you can see, students, very well, how much heat we are getting by the condensation of the complete steam, 540 calorie. But how much heat is needed to make ice water 100 degrees Celsius? Only 180 calories. So do you think that the complete steam will condense? No, complete steam will not condense because we don't need 540 calorie. We need how much? We need only 180 calorie. Okay. So in this situation, what we'll do here? We only need 180 calorie. Na? So we'll write here, please. Again, amount of steam condensed to amount of steam condensed to release 180 calorie is how much? You know Q equal to ml. So M equal to Q by M. How much we need? 180. And again I'm telling, M equal to Q by L. This is Q and this is L, 540. That means how much coming here? This will come here 1 by 3 gram. That means only 1 by 3 gram of steam will condense. That means now what will happen that here? Let's talk about here the situation. If we talk about here the mixture, first let's analyze the mixture. So first what will happen if we talk about the mass of water? You already know 1 gram of ice was there. This has converted into water and even steam is also converting into water. That means this 1 gram will come from ice and this 1 by 3 gram will come from steam. That means in the mixture what will be there? 4 by 3 gram water will be there. At which temperature? At 100 degrees Celsius. Okay. After that, students, if I talk about here mass of steam, how much mass was steam was there initially? 1 gram. But this has become water. So 1 minus 1 by 3. How much coming here? This will come here 2 by 3 gram. So mass of steam how much? 2 by 3 gram. At which temperature? At 100 degrees Celsius. Now you know very well heat always flows from high temperature to low temperature. But here you can see very well the temperature of the water how much? 100 degrees Celsius. Temperature of the steam how much? 100 degrees Celsius. Now any heat flow is possible? Heat flow is not possible. That means what will happen that here temperature of the mixture will be how much? 100 degrees Celsius. This is the temperature and this is the compositions. I hope so you have understood very well. Okay. Now students, I will solve one for you. Good question is there, but okay. Basics are needed. Now see here please. Next one, see please. 30 gram of ice at 0 degrees Celsius is mixed with 2 gram steam at 100 degrees Celsius. Find the final temperature and composition of the mixture. Now can you see one thing very well? Here the amount of steam is somewhat increased, but ice is also 30 gram of ice is there. Is it? That means what will happen in this situation? The quantity of ice is more. That means more chances are there. The temperature of the mixture can become 0 degrees Celsius. Okay. Let's see. So as the amount of ice is more, later you will see that here. Later you will see that if in case we have 1 gram steam at 100 degrees Celsius. So you know this 1 gram steam at 100 degrees Celsius can melt 8 gram of ice. Now you think and decode it. Okay. So see here please students. See. Now heat released to condense steam. Okay. Condense steam and make it water at 0 degrees Celsius. Amount of ice is more, so I have taken reference 0 degrees Celsius. Now you think first what will happen? Steam 100 to water 100, then water 100 to water 0. So steam 100 to water 100, we have to use the formula M into LV. Then water 100 to water 0, we have to use the formula MCW delta T. This much heat will be released here. Okay. So see here M how much given, mass of the steam how much? 2, and this one how much here? 540 plus again 2 into 1. Change in temperature 100. Now because water 100 to water 0 100. Now let's simplify this here. This will come how much here? 0, 2 4 ja 8, 2 5 ja 10. Now correct only, see the calculation 1080 plus here how much coming here? 2 into 100. It will come here how much here? 200. So it will come here how much here? 1280 calorie. 1280 calorie will be released when this steam is converting into water at 0 degrees Celsius. Okay. Now what will happen? See please. Now heat required. Now what is there? Heat required. Or like this we have to do the basic calculation. Heat required to melt ice and make it water at 0 degrees Celsius. Very easy. Now what is there? Just latent heat of fusion M into LF. Okay. Now M value how much? Mass of the ice how much here? 30 into LF 80. How much coming here? Just multiply here. 8 into 3 24. So 2400 calorie. So now you analyze the situation. We have to analyze it. How much heat we are getting? 1280, is it? But here how much heat is required? 2400 calorie heat is required here. Okay students, so here in this situation what will happen that just see students, we need 2400 calorie, but here how much releasing? 1280 calorie. That means students, the thing is that the ice will not melt completely. Ice will not melt completely because we need 2400 but only available 1280. That means the ice will not melt completely. What will happen? Only equivalent to this much heat ice will melt, rest of the ice will be as it is. Okay. So students, again I am seeing the calculation, I think so very well. Correct only. Now so now we are going to see the next one here. Okay. So see it please. Again amount of ice melted by how much heat is there? Amount of ice melted by how much? 1280. Amount of ice melted by 1280 calorie is equal to, again Q equal to ml, so M equal to Q by L. How much here? 1280 and here how much here? 80. Okay. So this 0 cancel, and after that just cancel by the 4. So 4 3 ja 12 and 4 2 ja 8, and here what is here? 4 2 ja 8. That means here what is coming here? 16 gram. Only 16 gram ice will melt. Okay. Now after that what will happen? That let's hear please. Mass of water. Mass of water. You know this 16 gram ice. Now this ice was there, na 30 gram. This has melted. How much melted? 16. So here what is happened? That this 16 gram ice is converted into water. And you think this? We was having the steam. 2 gram steam was there. That steam has also become water. Is it? So what is happening? 16 gram is coming from ice and 2 gram is coming from steam. That means in the mixture how much there? 18 gram water. At which temperature? 0 degrees Celsius. After that, if we talk about here, mass of ice, how much here? 30 gram ice was there. And how much melted? 16 gram melted. That means what will happen that here? 30 minus 16. How much coming? 13 minus 16 students? 14 gram. 14 gram. At which temperature? 0 degrees Celsius. Again, let's check out very well here. Initial mass should be conserved. So here 30 plus 2. How much here? 32. Here also, count please. 18 plus 14, it should come 32. Yes, it is coming 32. So again, you know, heat flows from high temperature to low temperature. Temperature is same only. That means what will happen in this situation? Composition is this is, but the mixture temperature. Now can you guess what is the mixture temperature, students? This mixture temperature is going to be how much? 0 degrees Celsius. Now very easy, very basic. You should know it. Okay. Now students, next one please. This is somewhat 5 gram ice. Before that, we have done 1 gram ice, then we have done 30 gram ice. I told you, amount of ice is more. But now 5 gram ice is there. This is not too much ice, is it? So here we have to analyze too much brain we have to use now. Okay. So the question is, students, see please, 5 gram ice at 0 degrees Celsius is mixed with 1 gram steam at 100 degrees Celsius. Find the final temperature and composition of the mixture. Okay. So you can take any reference, maybe 0 degrees Celsius you can take reference, 100 degrees Celsius you can take a reference. But when you will see the respective data, then the little bit common sense you will use now, you will get the idea. Okay. So see please, now I am going to do here, see, heat required, okay, heat required to melt ice and make it water, at 0 degrees Celsius. I have taken 0 degrees Celsius. Okay. So what will happen that 5 gram ice is there. Ice at 0, and now we are making water at 0. That means only what is needed? M into LF. Okay. So M how much given? 5. Latent heat of fusion 80. That means how much here? 5 into 80, 400 calorie. Is it? 400 calories needed. Now after that, this is the heat required. Now, but now we'll see heat released. Heat released to condense steam, okay, to condense steam and make it water, at 0 degrees Celsius, at 0 degrees Celsius. Now what will happen that here, again you think here steam is there, and now we want to make it a water at 0 degrees Celsius. That means again we have to go steam 100 to water 100. Steam 100 to water 100 means change of state, so M into LV. Then water 100 to water 0, that means again MC water delta T. Now let's put the value please. How much? Steam is there 1 gram, latent heat of fusion, vaporization, plus again 1 into change in temperature, water 100 to water 0, 100, is it? So let's hear please, this is 540 plus 100, how much is, students? 640 calorie. Now you use your logical brain. Now you use your logical brain. You think please, students, how much heat is required? 400 calorie. How much heat is required? 400 calorie. Is it? Required, correct? Heat required to melt ice. 400 calorie heat we required. But how much heat is released? 640 calorie. So you can see very well, our requirement is less, but release is more. That means you know what will happen that here, students. This heat will go into two parts. First part will what will tell you to this 400 calorie, and how much left? This 240 calorie will be left. This 240 calorie heat will increase the temperature of the water, because what will happen? Steam is becoming water and ice is also becoming water. So what will happen? Rest of the 240 calorie, it will increase the temperature of the water, whatever we have got here. Okay, student. So let's hear please. I told first and second, 400 calorie heat will use for this purpose here, and rest of them how much will be used here? How much left here? 240 calorie. This 40 calorie, this will do? This will increase the temperature of the mixture. Why? Because here also I have taken 0, here also I have taken 0. So after using this, 240 calories left here. Okay, students. So again, let me see here please again. 5 gram ice is there, 1 gram steam is there. Okay. So you know, students, again I'm telling here. Now I'm talking about here the mass of water, how much here? Mass of the water, how much here? 5 gram ice has become water plus 1 gram steam has become water. That means how much mass is there? 6 gram mass is there. That in a which situation? Water state. Okay. After that, if we talk about here the left heat, how much heat is left with us? Because 400 calories used to make ice into water. So how much left? 240 calorie. 240 calorie is left here. Now what it will do? This 240 calorie will increase the temperature of 6 gram of water. So what we'll use here? We'll use here, we know that the formula Q equal to MC water delta T. Now Q how much there? Q is 240. Mass how much? 6. Specific capacity of water is 1, and delta T again 100 minus 0. Okay, so students, here in this situation, temperature, oh, mistake happened, na? Because the temperature will become 0 to T, na? But now 0 degree Celsius is there, up to certain range it will go, T degree Celsius, so it will become here T minus 0 here, na? Up to what temperature it will go. So students, when you will simplify this T will come how much here? 240 by 6, 240 by 6, how much coming here? 40 degrees Celsius. Is it, students? So please remember that very well. Concept is very, very important. I have taken the time to explain you because this topic demands the time. Now, all the time I cannot make the video short, but I try to make this video as short as possible. Thank you so much.